Hello, so today we are going to do problems from bi-weekly contest 101, this week's bi-weekly. So the first problem is form smallest number from 2 digits array. So we get 2 arrays of unique digits, nums1 and nums2, and we want to return the smallest number that contains at least 1 digit from each array. So the smallest number that contains 1 digit from each array. What does that mean? So for example, we have these 2 arrays. What is the smallest number that we can construct that will contain at least 1 element from each array? Well, we can pick the smallest of this one, 1, and pick the smallest of this one and have 15, which will contain 1 of each. And there isn't really anything else that we can, smaller that we can do, right? We can do 4, 5, but 15 is smaller, right? The other variant case that can happen is, what if you have the same element in both arrays? Let's say 3 here. Then you can just return that number because then it's in both and it's the smallest, right? If we do the previous approach of picking the smallest from each one, so 1 and 2, then we'll get 12, which is not smaller than 3. So basically, if there is a common digit, it's always better to take it. So that's the idea. And the problem says that the numbers, individual numbers, are just single digits. So that's why it's better if there is a common one, it's better to take it. So how do we solve this? Well, pretty straightforward, right? We can just do, what we know is that we want the smallest number. So if we are not in this case where the number is in both, then what's the best strategy? Well, it's just to pick the min of each, right? And then pick the smallest of the two, put it first, and then the second smallest at the end, right? So what does that look like? So let's say here, so we have 4, 1, 3, right? And then 5, 7. Let's say even if we had more, like 8, and maybe 2, right? What's the better strategy? Well, we want the smallest number. So we already know that, and we will need, since there is no common element, we will need to get a number that contains digits in each, we need to concatenate those two numbers from the first one and from the second one. Now, to maximize our chances to get the smallest one, it makes sense to take the smallest of each. So we take the min of this one, which would be 1. We take the min of this one, which would be 2. And now we want to concatenate them. What's the best way to concatenate 1 and 2 to get the smallest one? Well, we can either do 2, 1 or 1, 2. Which one is better? This one is better. Now, what's this one? This one is just taking, let's call this M1 and let's call this M2. So which one is, what does this mean? Well, we want the smallest one to be in front, right? That's how it's going to be smaller. So we want the smallest one to be in front. And then next to it, we want the largest one of the two, right? Okay, so you could do this either with a string, like you could just convert each of them to a string and concatenate them like this, right? But the other way to do this also is, what's this? What's 12 like this? Well, this is just 1 multiplied by 10 plus 2, right? And so what this means basically here, instead of doing the string, you could just take the min of the 2, right, and multiply it by 10 to get it in the first position, and then add up the maximum one and put it at the end, right? Okay, and that's it. So this is the case where there is no intersection, so no intersection case. Now, what if there is an intersection? Well, if there is an intersection between the two, like maybe 3, 1, 4, 2, 4, and let's say maybe 1, 2, 1, 3, 5, like this. So we want to get the intersection between the two, which in this case it's 1, 3, right? And out of the intersection values, because we don't know, maybe it's just one value, maybe it's 2, maybe it's more, maybe it's a lot, right? We just want to, out of the intersection, because we want the smallest value, we want to pick the smallest one, which is 1, right? So pretty straightforward for the intersection case. And so in our check, we actually want to do the intersection check first and then do the rest if there is no intersection. So let's implement that. So it's going to be very straightforward here. We just need to get the minimum numbers and the intersection. So first, let's get the intersection, which is just converting each to a set, and then we get the intersection of the set with just AND operator. and then we check if there is an intersection, right? So in Python, you can either do this or check the length is bigger than 1. Then we want to just take the smallest one. Now, otherwise, we want to do this case. So we want to return this. And then, but we want to just call out what is M1 and what is M2. M1 is the min in the first array, and M2 is the min in the second array. That's what we did here. Nums2. Okay? And that's pretty much it. So let's run this. Let's submit. And this passes our test cases. In terms of time, we have this set, and so it's O of n being the length of whichever is largest of the two, and then the space time, we are not using any extra variables, so it's O of 1. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you in the next one. Bye.